the next session of ANSYS APDL. In this session, we are solving this numerical by using ANSYS APDL. Let's read the numerical. Calculate the rate of heat flow per meter square through a furnace wall consisting of 200 mm thick layer of chrome brick, a center layer of kaolin brick 100 mm thick, and an outer layer of masonry brick 100 mm thick. The unit surface conductance at the inner surface is 74 watt per meter square degree Celsius and the outer surface temperature is 70 degrees Celsius. The temperature of the gases inside the furnace is 1670 degrees Celsius. What temperatures prevail at the inner and outer surfaces of the center layer? The value of K, that is thermal conductivity, for chrome brick, kaolin brick and masonry brick are given. Assume steady heat flow, and these are the values which I have obtained by using numerical method by theory. The same numerical I have solved by using ANSYS workbench. Today we are solving this numerical by using ANSYS APDL. So let's get started. We'll first go to preferences, thermal, OK. Next I'll go to preprocessor, element type, add, edit, delete, add. I'll choose solid quadrilateral 4 node 55 as the element. OK. Close. Then I'll go to material properties, material models, thermal. Now you can see here, this is the first material that I'm solving for. That is going to be my chrome brick. So I'll give the value of K as 1.25. OK. I need to add two more material. So this is material ID 2. This will be my kaolin brick whose value of K is 0.074 watt per meter degree Celsius. And then again material new model. OK. Isotropic thermal conductivity will be 0.555 watt per meter degree Celsius. This is for masonry brick. So all the three materials have been added. Next I'll go to modeling. Create. This time we are going to use areas as the option. I'll go to rectangle by two corners. Now if you look at this question, you would know that the thickness is 200, 100 and 100 mm respectively for the three bricks. The cross section value is not given. So I will start with the first point being at the origin, so 0, 0. And the width is given as 0.2 for the first material. I'm taking in meter. And the height I'm assuming as 0.6 meter. Apply. Now this is my first brick. This is the cross section which I'm going to study. Next brick has the width of 0.1 meter. And the height is obviously going to be 0.6. Now you need to understand that I cannot take xy as 0 because then it will be overlapping on this surface. I want it after this brick ends. So this thickness, since it is given as 0.2, I will write here this is at 0.2 x value, y is 0. Apply. So you can see after the first brick ends, the second brick is going to appear. Now third brick obviously will be at a distance of 0.2 plus 0.1. So this will be 0.3 value of x, y is 0. The width is given as 0.1 for the third brick and the height I am assuming as 0.6 meter. Okay, so this makes my three bricks. This is a 2D problem that we are solving. The direction of heat transfer will be along the x-axis. Now this is done. Next I'll go to operate, booleans, glue, areas. Now this is used for gluing the three individual areas that I have created. So I'll select all three of them. Okay, so now they are glued to each other, which makes it a composite surface. So once the modeling is done, next we'll go to meshing. We'll use mesh tool. I'll change the sizing to smart size and let me say I'm choosing this value as 3. You can choose any other value. The more you bring it closer to fine, you will get a finer mesh. I'm leaving the number as 3. Then I'll go to global set. The first element type is 1 and element number is 1. That is my chrome brick. OK. I will choose the mesh from here. Mesh and I'll choose the first one. OK. So that's how I allocate the material and also mesh the body. Next, I'll go to mesh tool again, set. Here this element type will remain as 1. Element number I change it to 2. Okay. I'll go to mesh. I'll choose the second body. It is there. It's just that you have to click on it. Okay. So that's how I made for 2 bodies. Then I'll go to mesh tool again. Set. I'll give element number 3. Okay. Mesh. Choose the third one. Okay. So now my entire body has been meshed. Then I'll go to loads. I'll define loads, apply, thermal, temperature on lines. On this line, the value of temperature has been given to me as 1670. Okay. And on this line, again I'll choose this line. Okay. The value of temperature has been given to me as 70. Okay. Apart from these two, the value of convection has been given on this inner surface. The value is given as 74. Okay. So this completes my load conditions. Next, I'll go to solution, solve, current ls, okay, close, and close everything. Then I'll go to general post processing, plot results, contour plot, nodal solution. I want to first see the nodal temperature. So this is how my temperature variation takes place over the body. Also, I want to see the thermal flux along the x-axis. So this is the calculation value through ANSYS APDL. You can see the value is 945.88 and by theory I have got the value as 938.58. So the value is close. We'll find out these two temperatures also. So we will go to nodal solution, degree of freedom, nodal temperature that we have found. Now you can see here there's a dotted line which shows interface. So you can see the color change from red to an orangish color. The color changes over here. So when you see this color change, you can read the value over here is 1492.22. So that's how you can see this value, and here the value obtained is 1507.1. So that's a close value. I also want to get the other value which is at the other layer of kaolin brick, this second dotted line. This color changes from a dark blue to a light blue, I can see here, and that is seen over here at this end. So at this point I can see this value is 247.77. The value here is 238.7. Again the two values obtained are close. So that's how you can see the values at this interface of the two walls. Or I can say it is at the inner and the outer surface of the kaolin brick. So that's how we solve this numerical by using ANSYS APDL. I hope you have understood the procedure for solving this numerical through ANSYS APDL. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest updates of my videos. See you in the next session. Thank you.